Our libraries are full of records of past human achievement, much of that in written form. But people aren't reading books as much as they used to, and as a result our borrowing libraries, newspapers and bookshops are closing down. People now prefer to use the internet to get information, so what is going to happen to all the stuff written down on physical media? Booksellers have converted many of the most recent books and journals into digital form, and Google has done a great job at digitizing 30 million old books by photographing them and using optical character recognition to get at the textual content, and in many cases that's enough. But what about the manuscripts and old printed books, typewritten documents, handwritten letters and even old newspapers you can't OCR well, if at all? We can photograph them and put the images on the web, but then all that happens is that we stare at catalogues of page images or flip through images of a printed book on the screen and get bored. We often need to access the content so we can comment on it, format it, edit it to make sure it's correct, compare one version of the same work with another, or to study it. Often for works that are important, there are already transcriptions of the content, or people are willing to transcribe them for free through crowdsourcing. But is that enough? Is plain text sufficient to capture all the details of the original? What about complex mathematical formulae? What about inline pictures, doodles in manuscripts, the look and feel of the original, the nature of the medium on which it is written, the erasures and insertions, the original layout, the notes written in the margin, the tears and gaps? To read the transcription without the original document to hand impoverishes the information it once carried. The way Adobe and Google do it is to put the rough transcription on top of the page image. That's good in that it makes searching a document intuitive. You search and copy the text that you see, and the formatting of the original is preserved. But is all we can do with this material really limited to search and retrieval? One alternative is to put the text next to the page image, but this creates a lot of user interface problems. Consider the simple problem of scrolling through a text. You start at the beginning and everything is fine. The text on the left is the same as the text on the right, but as you scroll down, the transcription soon goes on to the next page. Now you have to update the page image. If you ask the user to do that, he or she will have to choose the correct page image from a menu, and that's really inconvenient. So at a minimum, the page images and their transcriptions will have to be linked so that they automatically refresh as needed. Now consider the problem of line breaks. In a printed book, lines break in the middle of words all the time. That's hyphenation. So your choice in transcribing the text is to remove these line breaks and join up the words, or to preserve them and show them. If we take the first option, the text will flow differently from the original, and that makes it hard for the reader of our electronic text to connect the relevant part of the page image with the transcription. And the reader needs to do that to make use of the added information provided by the image. A word in the middle of one line in the transcription might have originally been split over a line, so the reader will spend a great deal of time trying to find out what corresponds to what, even if the text in the page image is absolutely clear. Now consider what happens when the text preserves line breaks. Even in this case, the number of lines per page on each side of the display will be different, and maybe the text in the original is in multiple columns. The best the reader can do is to line up one line of type in the image with one line of type in the transcription. And what happens if there is not enough room to display the full line width? Then the text will go off the right edge of the screen, or it will wrap around and look awful, and be confusing. But what if we provided some cue for the reader to link each word in the transcription with each word in the page image? For example, if we highlighted the words on each slide simultaneously, when the user moved the mouse over or tapped a word in which he or she was interested, then the corresponding word in the image or vice versa could be highlighted, and the transcription could even be scrolled up or down automatically to bring the two renditions of a text into alignment. The technology to do all of this exists, and various folks have already created tools that follow this model, but there are still two key problems they haven't yet solved. The first problem is automation. You can draw neat rectangles over words in an image or even polygons, but doing that by hand is extremely time-consuming and dull. After a couple of pages, you think you are going mad. We need some way to automate the connections between words in the image and words in the text to make this practical on a large scale. And the second problem is how to represent the links and the shapes to be highlighted in the image. the shapes will need something in the text to link to. All of the solutions so far proposed use markup, that is, they embed computerized tags into the transcription to represent the links. But at the same time, you also need more markup to represent the formatting structure of a transcription. The proponents of embedded markup have concluded that, because of this conflict, you actually need two copies of a transcription, one marked up for the image to text links and another for the formatted text, because otherwise it gets too complicated. But the end result is that the same information gets represented twice and needs to be edited twice in precise synchrony every time you need to change something. So the result of these two problems is that text-to-image linking has reached an impasse. It's just not happening on any significant scale, but it is still undeniably useful. To solve these two problems is the motivation behind TILT, text-to-image linking tool. The TILT name is also meant to imply that it can handle text that is warped or at an angle in the page image. The usual idea in optical character recognition is that if the text is warped or tilted, then it must be corrected before you can start recognizing the words. But in manuscripts that is just not possible. Lines are not always written nice and neatly in regimented lines, and they're not always oriented in the same way throughout the page, but they are still recognizable as lines. What TILT doesn't attempt to do is to recognize text. Recognizing text in a manuscript is too hard. Different writing styles are simply too different to be reliably converted into plain text. But TILT does try to recognize word shapes, and in so doing it borrows some techniques from OCR. The first step is to work out where the text is. This will be possible in the user interface by specifying which blocks are text and which are not, and if necessary, how they are to be rotated. Then TILT can break an image into areas for word recognition. But let's assume for simplicity that there is only one text block and that the text in it is fairly horizontal. The image has to be reduced to plain black and white for processing, otherwise TILT won't be able to work out if there is a pixel there or just a dark shade of red. And that's harder than it seems, because lighting in an image can be very uneven, and turning it into black and white can result in half the image being white and half black, so almost no text will be readable. But using OCR techniques, this is straightforward. Next, it has to be cleaned. Borders and black blobs or long lines have to be removed, etc. Again, this is a standard OCR step. Now we have to find the lines. The way TILT does this is that it divides up the image into columns and rows. Then it counts the number of black pixels in each rectangle. If the number of pixels exceeds the average for the image, it is taken to belong to a line, and the lines are then joined up across the page. The reason for doing it this way is so that the lines may go up or down, or still be a bit slanted. OCR programs can't recognize lines in this way. Next, we need to find the words in the lines. TILT looks along the lines and extends out any connected pixels and joins up any broken fragments of text that are separated by less than an average word space. It can define polygonal or rectangular word shapes depending on your preference.
The final stage is to compare this collection of lines and word shapes with the words in the corresponding text transcription. You might think this is hopeless, given that the content of the words in the page image have not been determined. On the contrary, there is plenty of information to align the two because the succession of widths of words in both the page image and in the transcription is known. It's like a Morse code, dash, dot, dot, dash, except that many more than just two lengths are allowed. By aligning up the two sequences of words lengths, the approximate alignment between the text and the page image can be made. In printed text, this might even be good enough to use without further editing, but in other cases it will doubtless get it wrong. That's where the user interface comes in.
Let's say that the alignment is wrong by the time we get to the page end. It might be, say, 5 words out of kilter. But then the user could specify that the last word on the page is in fact aligned with a certain word in the transcription. Then by asking TILT to realign using this human input as a guide, it will likely get it right the second time. If not, then further anchor points like this may be needed. Or maybe the word shapes are themselves wrong. Then the user interface will need to allow editing of the shapes. This makes more work, but it is necessary if the result is to be accurate. We said we would automate things as far as possible, not make it completely automatic. So the user interface has a lot to do, and it is quite a separate thing from the main program. One resides on a server and has no visible interface, and the other is a user interface and has no power to recognize words or lines. Our user interface will use the latest web technologies and be compatible with every main browser. Finally, we come to the problem of how to store these links. To get around the second problem outlined above, Tilt doesn't embed markup or tagging into the transcription. Instead, it represents it externally and projects it over the text. So one layer of this projection is reserved for the format and another for the text to image links. They are both added to the plain text when needed, and the result is an ordinary web page that behaves in the way described above, that areas in the image get highlighted as you move over the words with the mouse or tap them with your finger. So that is Tilt. Where we are at this stage of the project is that we have the page preparation and line recognition done and are working on the word recognition. The text-to-image linking is already done from an earlier version of Tilt, where it worked well. After that part is complete, the user interface needs to be written and user tested in various projects that have expressed an interest in using Tilt. Thank you for listening.